22. All right, so everybody's got their books open to chapter 3 homework. True? Everybody's got a book they can see? 22, 34, 35, 37, 38. Okay, now, again, I want to be really clear, because some of you, when you were doing your homework, and I turned it in last chapter, like you would write down as much as we wrote down in class, and then you'd stop there. When I stop in class, the only reason I'm doing that is because I want to move on to other things. That doesn't mean that we're finished with the problem necessarily, right? So you may need to put a big star by it and say, come back to this to finish. Okay? Just want to make sure that's really clear. Taking a look at number 22, that's the first one that was asked about. It says a girl delivering newspapers travels 3 blocks east, 3 blocks west, 4 blocks north, 6 blocks east. What is her resultant displacement, and what is the total distance she travels? Was it part A or part B that was...
Wait, it's actually 27.
Oh, she's changing her story. Gee, I'm just teasing. It's all good. 27. A person walks 25 degrees north of east. For some time, how far did she go north? How far did she go east? So, I would graph it. 25 degrees north of east. Where's that going to be? North of east. How do I get there? Start at east, turn north. 25 degrees north of east, so something like this. Is that okay? And then I want to figure out the east part and the north part. So part of it's going over like this. That's going to be the adjacent side of that triangle, right? So I think you're going to use cosine for that one. And then the north part is going to be the opposite side, so you're going to use the sine. Okay. So this was 310, or 3.10, excuse me. So, like for this bottom one here, we would say that the displacement in the x, adjacent over hypotenuse, so over 310, is equal to the cosine of 25. Does that make sense? Does that statement help a little, Inti? Okay. Does that get people where they need to go on a question like that? Yeah? Okay. Can I go on? Is that okay? Okay. 27 done. 34. The fastest recorded pitch in Major League Baseball was thrown by Nolan Ryan in 1974. I don't know if it's still the fastest recorded pitch. Maybe. This book was published a while ago. If the pitch were thrown horizontally. So they're trying to make your life easy, right? So this is like a case 1 situation. So he released from up here saying that it had a velocity that was directly horizontal to start. We just need to write down some stuff. So let's make our list here. dx, vx, ax, dy, vy, ay, and t. Take a look. Even if you did this problem a long time ago and you got the right answer, good for you. You can still help us out. Everybody should look on page 115 at question 34 and raise your hand with a given that I can write down. Everybody should be able to tell me something. John, what you got? dx is 18.3. Is everybody okay with that? It says that that's, by the time it reached stone plate, it was 18.3 meters away. I think that's good. Fantastic. Inti, what you got?
dy is 0.809.
0.809 is dy. Do you guys agree with that?
No, it's negative, right?
It needs to be down, right? Because the ball is falling. Okay? Almost always dy will be negative unless it's 0. Almost always. So always check that. Did you have something, Madison?
Yeah.
What you got?
Acceleration for y is negative 9.81 meters per second squared.
Because it always is, right?
Always.
Boom.
Unless it, can I get another one?
No, we want to share the fun. Zach?
Acceleration for x is 0?
Yeah, because it always is, right?
Yeah, that's the question. That's all.
Sweet. Anything else you know? Anything else you know? Go.
Velocity of y is 0 meter.
Why do you know that?
Because acceleration is constant.
Excel.
Acceleration is constant.
And that's why Vy is 0? I agree with both of those statements. But my question is, how do you know that the initial velocity in the y direction is 0? Who can help him out? I don't want to talk to the same people I always talk to. Go, Sean.
Because it started out just going straight and then it started going down.
What word do you see that says that to you
Like,
in the problem? What does it say? What does it say, Maya?
Horizontal.
Horizontally. Ladies and gentlemen, if you see the word horizontally, this might be something to write down in your notes or on your homework or somewhere where you will see it when you're working on problems like this. If it says horizontally, then you know that Vy initial has to be 0. Okay? This is what I call the case 1. Horizontal is case 1. Once you have this set up, can you solve this problem? Does anybody need a push in the right direction from here, or are we okay? Taking the lack of questions to be that we're okay. I don't remember who asked about this problem. Does it make more sense now or okay? Okay. All right, may I move on? Is that okay with everybody? Okay. Let's take a look at number 35. 35 says a shell is fired from the ground with an initial speed of 1.7 times 10 to the third meters per second at an initial angle of 55 degrees. Neglecting air resistance, find stuff. A note on number 35, if you haven't yet done it, B should come before A. I don't know why they put them in that order. It's really silly. Like, I have no idea. I kind of want to ask somebody because it doesn't make any sense. 35, you want to find the time first. So in this case, this is like a case 2. It's kind of like the football problem we did last time. The initial velocity is now like this at an angle. I guess I didn't draw that very accurately, but you get the idea. Something like that. dy, vy, ay. Oh, excuse me, those should be x's. Got ahead of myself. There are my y's. I want to talk to different people. Give me a given for 35. Go, Jake.
Vx is 1.7 times 10 to the third.
Is it all the 1.7 times 10 to the third is in the x direction?
Oh, no, it's the velocity, just that arrow.
So this arrow, right, is the 1.7 times 10 to the third. Does that make sense to everybody? That is the actual initial velocity. What is Vx going to be equal to? Go, Anna.
Cosine of 55 times 1.7 times 10 to the third.
Yeah. Is that okay with everybody? Does anybody have any issues or questions with that? Please ask if you do. So it's the initial velocity, but it's just in the x direction. So it's just this piece here. Vx over Vi equals the cosine of theta. Because it's the adjacent part. Is that okay? All right, I've got one given written down. Want to talk to new people. There are 29 of you in here. I've already talked to you. Want to talk to new people. There are 2 that are really easy. Actually, I would say 3 that are really easy. What you got for me? Go, Tim.
Delta y equals 0.
Delta y equals 0. Why is that?
Because it's ending up on the ground from which it's launched off.
Boom. All right. Yeah.
The acceleration in y is negative 9.81 meters per second squared.
Awesome. Because it always is, right? Fantastic. We're getting closer. Melissa, go ahead.
Would Vy then equal 1.7 times 10 to the third times sine of it?
Yeah. Nice. Good job. All right. One more thing that I should be able to fill in. Zach's going nuts back there, but I'm not going to talk to him because I've already talked to him today.
Audible.
Sorry.
Wait. Can I go to the bathroom?
No, not yet.
Oh.
I've already talked to you, Jake.
Kevin.
Talk to somebody at your table. Have a conversation. Figure out what it is. This is silly. This is silly, right? This is the easiest of all of them. If you have not yet said anything, then put your hand in the air right now. Up high. Wave it in the air just like you don't care? What? Rowan, do you know what it is? Acceleration of the x is 0. Is that what you were going to say, Ashley? Is that what you were going to say, Kevin? Oh, now I'll never know? I guess you'll have to raise your hand again so that I can ask you again. Oh, I can wait. I'm a patient woman. All right. Yes, ma'am.
I'm confused by the Vx and Vy.
Okay.
I thought we were to find those using the equations where the Vx over Vi equals cosine beta.
You can. Like, you can plug it in to get the number.
Right.
Yeah, is that what you're saying?
So, well, I'm confused. What that is. Oh, I see. Got it.
So, like, you can plug these numbers into your calculator and you'll
I
get
didn't
something.
see the extra rating.
Yes.
Got
Is that
it.
okay?
Yeah.
Okay. All right. So, part B I said is better to do first because it wants to know the time. How do you find the time using this information? With the equation, right? The best equation. The favorite equation. The coolest equation on the planet. Like maybe this one?
The one that you can lose half of by with 0.
You can get rid of stuff with zeros, right?
What's a 0?
What zeros do we have in this one? Friends, think before you speak. We're looking at the y stuff. Are you with me here? Because we have all the y stuff. What in the y column is 0? This one, right? This is a case 2 problem. dy goes to 0. Can you solve this for time?
Yes.
Yes, we've done this. I have to give you the friendly reminder that I'm sure you heard last semester, or if you didn't, you should have. This is accelerated physics, which means that we have to go what?
Fast.
Fairly quickly, and we have, you know what I'm saying? I don't have time to go over this 7 times with you. We went through this last time together, right? Okay? It's recorded. I'm putting it up on YouTube. You can watch it every day from here until forever. That's fine. But you need to make sure that you understand how to do this stuff. And if you don't, then come ask me. Okay? I'm going to go through it one more time because I want to make sure you get it. How do I get TL by itself?
Algebra.
That would be like, how do you get from here to San Francisco? Drive. Like, okay. Could you use something a little bit more specific to tell me, Madison?
You subtract Vy over Vyt over.
Okay, so negative Vyt is equal to 1/2 Ayt squared.
And then, anybody else want to answer?
Divided by t.
Divide by t, but don't tell the people downstairs because they get mad. And then get TL by itself, right? Yeah. Can it be done?
Yes.
Okay. So that's how you solve part B. Then you get an answer for part A or for part B, and then use that to find the displacement in the or in the x direction. Is that okay? Questions, issues, concerns here, friends? We good? All right. 35 is done. 37. So 37 is just a double problem. 37 is just like the Nolan-Ryan problem. It's a horizontal problem. You've got two people in boats. Whoa, my computer's got a mind of its own today. Your waterfall. So here's one boat. That's the boat with the speeder. And then you've got another boat. That's the boat with the official. I don't know what they're official about. But they're going to go off into the water below, right? Which one's going faster? The official are going faster? Yeah, the spy is only going 15 meters per second, so he's going to land splash here. Where is the official going to land relative to him? Farther out. Does that make sense? He's going faster. He's got more initial velocity in the x direction. So he's going to splash further out somewhere. Can you find this distance dx for the spy? Do you understand how to do that? Can you find this distance dy for the official, or dx for the official? Once you do that, subtract them, and that's what they want to know. So this is one of those super secret ways that they have to write questions to make you do two problems in one. Who's going to hit the ground or hit the water first?
They have the same acceleration when it comes to y, right? So they have to be the
Same acceleration comes to y, and they have the same initial velocity when it comes to the y?
Yeah.
Yes. So they will have the same time.
So you have to find one time and then use both.
Right. But different dx values. Is that okay? Does that make sense to people? Questions about that one? Do you feel like you can do it now?
If we use the same equation to get time as we did up there.
Not this one, because this one is the one with dy equals 0. You're going to use the same thing you did here. So it's the same, the big long equation is the same, but the derived equation will be different. It'll be the exact same as the Nolan-Ryan situation, though. So it'll be this thing will be 0 this time, because the initial velocity in the y direction is 0 since they're going off horizontally. Does that make sense?
Because I have the initial velocity for the y is 26.
That would mean that he's going straight up 26 meters per second.
Okay.
Do you see what I'm saying?
Yeah, so then that would be...
Which would be exciting. That might be more fun to watch. I don't know, but...
So then y initial velocity would be 0?
Correct. Yep. Yep. They're both. So they're going along in their boats, right? Speeding along some crazy high-speed chase, and then they get to the waterfall, and they're going to come off exactly horizontally. So that means that their y velocities are going to be 0.
Okay.
So all the measurements will be the same except for the velocity?
Yes. Correct. If you need to go, you can go. Okay. Last one was 38. All right. Last one. Here it comes. Ah. Why are you being ornery? Okay. Hold on. Let's just make ourselves a new page. All right. 38. A place kicker must kick a football from a point 36 meters from the goal. As a result of the kick, The ball must clear the crossbar, which is 3.05 meters high. When kicked, the ball leaves the ground with a speed of 20 meters per second at an angle of 53 with the horizontal. Okay. Part A says, by how much does the ball clear or fall short of the crossbar? So if we draw this picture, so here is the crossbar, okay? And the crossbar has a height of 3.05 meters. Is everybody okay with that so far? So the football is over here, and it's going to be kicked with some trajectory so that it either goes up and over, I guess it could hit the crossbar, or it could go down below. We don't know. We know for sure that it's going to go how far in the x direction? 36 meters. So this one, I would approach this question kind of like that question with the girl throwing the apple up to her friend. And the question was, does the apple get to the friend or does he catch it or something like that? Okay. I would approach this the same way. dx, vx, ax, dy, vy, ay, and t. I would say that I know that dx has to be 36 meters because the ball has to get this far. Do you agree? If it only gets to 30 meters, then obviously it's not going to go over. Okay? So let's assume it's going to get to 36 meters. And let's find out when it's at 36 meters, how high up is it? Are you with me there? When it gets to 36 meters in the x direction, how high up is it? So let's find dy. Let's make that our question mark. If it's more than 3.05, he scored. If it's less than 3.05, it's no good. Okay? You've got an initial velocity like this that we're going to break down into x and into y. So this is going to be vi times the cosine of theta again. This is going to be vi times the sine of theta. Hey, what's ax? I'm going to ask that again. I want to hear a resounding answer because there are 28 of you in here, so you can answer that question. Hey, what's ax? 0. 0 what? Fantastic. This one should be just about as easy to answer, if not as easy. What's ay? Okay, there were at least 4 people that I saw that didn't say that, which means that we need to try again. You should know this, friends. Let's try again. What is ay? -9.81 meters per second squared. Good. There we go. This one's a little bit different. Hi there, thank you. I appreciate that. Almost every problem that we've done in the past, we had to do the dy stuff first. Do you remember that? Does that sound familiar? This one, we have all the x stuff. So I do the x side first, which is going to make your life easy because that gets rid of the t squared business. Use that to solve for time, and then solve for dy. Does that make sense? Is it doable? Okay. Any questions that you have right now? Use x to solve for time, and then use the time to solve for dy. All right. Any other homework questions? Okay. So you don't have any more homework that's due, except what's been assigned already. So that means that if you need to go back and fix stuff, doing that this weekend would be a good plan just to get it done and over with. Okay? Go ahead and put that